Hello, hi everyone. I hope we are live. Hello, hi everyone, and welcome to this video. In this video, we are going to discuss the solutions of the contest, weekly coding contest 126. So, first of all, please let me know in the comments if I'm properly audible, and let us wait for some more seconds for more people to join, and then we'll begin. Am I properly audible? Okay, great. Okay, thank you. So let us start with the first question because first a few were very quite easy. So by the time we discuss them, more people will join. Okay. So let me share my screen. I hope the screen is visible. Okay, great. So let us start with the first question, that is maximum occurring digit. Given an array of n positive integers and a digit k, find the number with the maximum occurrence of k. In case there is more than one such number, return the smallest number. If k does not occur in any number, then return -1. So basically, what does this question say is, this is the first question. So the question is saying that we are given n positive integers, okay, and we are given a digit k. Digit k means it will be a digit from 0, 1, 2, 3 up to 9, okay, and we need to return the number out of these n positive numbers which has maximum occurrence of k. Okay, and if multiple numbers are there who have maximum occurrence of k, then we will return the smallest number. Okay, so for example, let's say if k is 4, okay, and n is equals to 4, so there are four numbers in the array. Let the array be 4, 404, 30, and let's say 40, 454. Okay, so here the occurrence of k, that is 4, is 1. Here the occurrence of k is 2. Here the occurrence of k is 0. And here also the occurrence of k is 2. So the maximum occurrence of k is in this number and in this number. But we will return this because if there are multiple numbers who have the same occurrence of k, the maximum occurrence of k, then we return the smallest one. Suppose I had one more number 44495. Here k, that is 4, is occurring 3 times. So then our answer would be this because it has the maximum occurrence of k. Okay, is the concept clear? So what we will do, for each individual number we will count the number of occurrences of digit k in it, and out of all the possible values, whichever will have the maximum count, we will return it. And if there are multiple numbers with the same maximum count, then the smallest will be returned. Okay, so let me take the code here. So basically I have taken one variable max count, which will basically store the maximum count of k among all the numbers. I have taken answer equal to -1 initially. I have taken c to count the occurrence of k in individual elements, and I have taken variables I and j. Now I will traverse from I equal to 0 to n, and I'll make count variable equal to 0 initially and j equals to array of I. Now at every point of time, I can access the last digit by saying j modulo 10, right? And I want to see how many times k occurs in it. So while j is greater than 0, if the last digit in j is k, then increment the count, and at every step divide j by 10. Okay, so at every step, suppose the number is 3334, then first of all 4 will be compared with k, then number remaining will be 333, then 3 will be compared with k, then the number remaining will be 33, and so on, okay, until it becomes 0. Now if the count of k in this number is greater than max count, then we update max count value and also answer value equals to array of I. Else, if count is equals to max count. Okay, if the count of occurrence of k in this number is equals to max count and the value of the array element is less than answer, then also we update the answer variable. Why? Because in case of multiple elements having the same max count, the smallest one is taken, right? So we take that, and finally I will return the answer. Okay. So this problem is solved successfully. Any doubt in this? Why is there a penalty on compilation while submitting? I got a compilation. I think it should be corrected. Okay, I'll talk with the software team if there is anything to be changed. Let me take a screenshot of this so that I do not forget. I missed just by one check because I thought array was shorted. Missed this one today. Was the given array unshorted? Yes, there is no information about the array being shorted or unshorted. So I think we will assume it to be unshorted. But even if it is shorted, like why? How you? I think you need to check all the elements also, na? Even then or not, because a larger element can have more count of k also, right? So I think you need to check all the elements even if the array is shorted. Please share your code. Okay sir, please explain one with example, the if else block. Okay, so I'll also share the code, but I'll just share this with the, I'll make you understand the if else block. Okay, so what is the if else block saying? If count is greater than max count, then update both. Else if count is equals to max count and array of I is less than answer, then update it. So what it basically saying is, consider this example. Okay, initially your max count will be equal to 0, your answer will be equal to -1. Now when you come across this element, k is 4, so number of 4s in this is 1. So if count is greater than max count, this will be true because count is 1 and max count is 0. Then we will update max count as count, so max count will become 1 and answer will be equal to array of I, so answer will become 4. Now when I will come here, my count will be 2 because there are two 4s in it. Again count is greater than max count because max count value is 1. So again I will update max count as 2 and my answer will be updated as 404. Okay, do not take this element for now. Then I will come here. Here the count is 0 because there are no 4 in the number. So count is not greater than max count. Okay. And in the else if block, what it is saying, if count is equals to max count, that is also not true because count is 0 and max count is 2. So here neither if statement nor else if block will be executed. Then we come here. Okay, here my count is 2 and my max count is also 2, so my if statement will not be executed if count is greater than max count, no. But else if count is equals to max count, yes, this is true, my count is 2 and max count is also true. Now it will check the second condition. If array element is less than answer, so is array element less than answer 454 less than 404? No, so it will not change. But suppose instead of 404 here the element was, uh, let's say here it was 454 and here it was 404. Okay, so here my count would have been 2, which would be equal to max count, and 404 was less than 454. Are you getting my point? So again my answer would be updated as 404. Here my answer would be 454. Okay. So if what is said in the question, in question they said that, in question they said that if there are, see, if digit k, in case there is more than one such number, so if there are multiple elements with the same maximum count of k, then we need to return the smallest number. So if we get a element count which has same as max count but its value is less than answer, then we will take that as answer because we need to take the smallest. Now is it clear? Also let me share the code. Oh. Okay, great. So code for first question. Okay, we'll move on to the next question. Geeks plants. Okay. There are nearly 25 people. Thank you. I totally understand. Okay, welcome. There are nearly 25 people in the stream. I would ask everyone to like the stream if you are liking the video solutions and if you are understanding. Also, if you like these solutions, you may take a screenshot of the screen and share it on LinkedIn, tagging me and Geeks for Geeks. Okay. Thank you. Now let's move on to the next question. Geek wants to plant water n plants numbered from 0 to n minus 1, where plant I requires ARRI units of water daily. Okay, so what it is saying is there are n plants in which Geek needs to fill water. Okay, and ith plant needs ARR amount of water, that is array of ith element amount of units of water daily. Okay, this much water is needed daily, and these n plants are numbered from 0 to n minus 1. Okay, Geek has to use buckets of same size and cannot use a bucket more than once in a day. Okay, so Geek wants to use some buckets to apply water to these plants, and the bucket should be of same size. Also, one bucket cannot be used more than once in a day. Cannot be used more than once in a day. Okay, more than once. So that is greater than one. Okay. Also, Geek does not waste any water. Find the minimum number of buckets Geek needs to use daily for watering the plants. Okay, so what it is saying is that it also does not waste water. Okay, so water should not be wasted. Okay, does not waste even a little amount of water. So what are the minimum number of buckets required to water all the plants daily? Okay, note each bucket can be designated for one plant after receiving a fresh refill of water at the beginning of each day. Okay, so what they are saying is that suppose you have m number of buckets, and at the beginning of each day this will be refilled. Okay, all the m bottles. Now one bottle can be used for only one plant. Okay, so you cannot say suppose my first plant requires 1 unit of water, second requires 2 unit of water, third requires 3 unit of water. You cannot bring a bucket of 6 units of water, apply 1 unit here, 2 unit here, and 3 units here, right? So no water will be wasted and only one bucket will be used to plant all of them. But that is not the true, because one bucket can be used to water only one plant. For one plant you can use multiple buckets, that is okay. Suppose one plant requires 6 units of water and you have bucket size of 2 units of water, you can use 3 buckets to filter just to water just this plant. Okay, but one bucket cannot be used for multiple plants. Now understand one thing, all the buckets should be of same size, right? You cannot use one bucket to filter multiple plants, and you also does not want to waste water. Okay, so can I say can I say the capacity of each bucket, the capacity of each bucket, which should be same, okay, or the size of each bucket should be same, should be divisor or factor of each array of I, right? Because let's say first array of I, first plant needs 6 units of water, so I can use either 6 buckets with one capacity, or I can use 3 buckets with two capacity, or I can use 2 buckets with three capacity, or I can use one bucket with six capacity to water this plant. Okay, in this way I will not use these buckets to water other plants, and I will also not waste water. Okay, but let's say my another plant has requires 9 units of water to be filled daily. Now, if I use 6 buckets of 1 unit to fill this, now all the bucket size should be same. So I have fixed the size, that is 1. So here I will require 9 units. That is okay. That will work. If I use 3 buckets of 2 units, now the bucket size is fixed 2. So here I can use 3 units, but here I cannot say I will use 4.5 units of bucket. Are you getting my point? Because each bucket has capacity 2, right? And I do not want to waste any water, and one bucket can be used for one plant only, right? So I cannot use buckets whose capacity is 2, because they will not work in case of 9. If I use 2 buckets with capacity 3, I can use 2 buckets with capacity 3 here, and I can use 3 buckets with capacity 3, so that will also be equal to 9. This will also work. If I use one bucket with capacity 6, I also need to use other buckets of capacity 6. So here I can use one bucket, but here I cannot say I will use 1.5 buckets. There is no 1.5 buckets. Okay. So there are two possible cases if you have two array elements, 6 and 9. Either you use 1 units of bucket to fill both of them. Here 6 buckets will be used and here 9 buckets will be used, or you use three unit size buckets where year 2 will be used and year 3 will be used. Here the total number of buckets used are 15. Here the total number of buckets used are 5. So our answer would be 5. Is this much clear? Let me know. Right? So now we know that the bucket size should be same for all the buckets. So the bucket size, and we do not want to waste water, and one bucket can be used to water only one plant, right? So one so the bucket size should be divisor of each element of the array, right? Now if it should be divisor of each element of the array, and if I want to use the minimum number of buckets, then I need to choose a number which is a divisor of all the elements of the array, and its value is as large as possible. For example, here I used the bucket capacity to be 1. Here I used the bucket capacity to be 3. Since I used 3 capacity bucket, I needed 5 buckets. Here I used 1 capacity bucket, so I needed 15 buckets. So I will choose 3, right? So what is the maximum number which is the divisor of all the numbers? It is nothing but greatest common divisor of all the elements of the array. So if I find greatest common divisor of all the elements of the array, that would be the bucket size. Then what I can do, suppose my GCD is equal to G, then the number of buckets will be summation I equals to 0 to n minus 1 array of I upon G, because this is the bucket capacity, this is the amount of water which I need to apply to ith plant. So for ith plant, I will require array of I divided by G number of buckets, and the summation of buckets over the complete array will give me the total number of buckets, right? So now let us have a look at its code. Okay, so what I have done, I want to count GCD in the variable G. So I have said G equals to array of 0, and then I have traversed from I equals to n minus 1, and G equals to GCD of current GCD and array of I. Okay, now in the function, I wanted to pass the first element to be max and second to be mean. So I passed max of G array of I and mean of G of array of I. But what I mean is G is nothing but GCD of GCD calculated till now and array of I. Okay, and this is the Euler's GCD function, where GCD of AB is if A modulo B is 0, return B, else return GCD of B comma A modulo B. Okay, so this gives the GCD value between two numbers in very small amount of time, almost constant. Okay, we are not going to look at the proof. So I got the G, that is the GCD of all the elements of the array, which will be the capacity of each bucket. Why? Because one bucket can be used for only one plant. Okay, one plant can have multiple buckets to be used, but one bucket can be used to water only one plant. No water should be wasted, so the bucket capacity should be a divisor of capacity, or should be a divisor of the amount of water to be applied to each plant. And we also do not want to waste any water. So okay, and we want minimum number of buckets, so G should be as max as possible, which is nothing but GCD of all the elements of the array. Then I have traversed the array, and I have said answer equals to answer plus array of I by G. Array of I is the amount of water to be given to ith plant. G is the capacity of the bucket. So the number of buckets required to filter ith plant is array of I by G, and that summation will be stored in answer. Okay. I was getting TLE. No, you should not get TLE. Then you might be using the basic method for loop to find the GCD. Why use mean and max here? Okay. So basically, I'll tell this. See, what is my function? GCD function. It says that int GCD int A int B. Okay. So here I am assuming that A is greater than equal to B. Okay. So assuming this, I have written if A modulo B is 0, then return B, else return GCD of B comma A modulo B, right? So here this function I have assumed that A is greater than equal to B. In that case, I have checked here A modulo B equal to 0. Otherwise, so in order to do this, what I have done while calling the function between G and array of I, it might be possible that array of I is greater than G. Okay, and I want A to be greater than equal to B. So while calling the function, I made sure that the first element is max of both these elements and the second element is the mean of both these elements. Okay, so that's why I used the max and mean function. Is this clear? Okay, we'll move on to the third question. Okay, thank you for liking the live stream. Many people have liked it. So let us move on to the third question. Yes, you can also do that. If G is greater than A of I, just swap G and A of I. Basically, in that function, I want that A is greater than B. So if B is greater than A, in the function, you can swap. That will also work. Okay, let's move on to the third question, that is cyclic tree. In the given tree, an additional edge exists between any two nodes, resulting in the presence of a cycle. Okay, great. So let me first tell you a brief about this question, then we'll move on to this theory part. Okay, line by line. So what this basically cyclic tree question says is, there is a graph with n nodes and n edges, and there is one cycle. Okay, now we know that if a graph has n number of nodes and n minus 1 number of edges, and if this is connected, what is the meaning of connected? There is a path between any two pair of vertices, then this basically forms a tree. Now in this tree, if I add an additional edge, if I add one more edge, okay, additional edge, then this becomes a graph with one cycle. Okay, so for example, if I have four nodes, okay, so this is 1, this is 2, this is 3, and this is 4, this is tree. Now if I add one more edge between two nodes, okay, no self loops, and so let's say I add an edge between this and this, so I got one cycle here, right? So basically in the question they have said that you have a graph with n nodes and n edges which has one cycle, or you can say in other terms, you have a tree with n nodes and n minus 1 edges, and in that you added one additional edge. That is what is given in the question. Now they are asking that, can you replace one of the edge, can you replace one edge of cycle and add new edge such that you get cycle of same length. Okay, so what is the meaning of cycle length? Cycle length is the number of edges in the cycle or number of nodes in the cycle. For example, this is A, this is B, this is C, and this is D. So here we have a cycle A, D, B, A, which has basically three number of edges or three number of nodes. So they are asking whether I can remove one edge in this cycle and add a new edge between any two nodes such that I again get a cycle with same number of length. Okay, so let's say I remove this edge between A and D, so my graph will become A, B, D, and C. Okay, now if I add an edge between A and C, I again get a cycle A, B, C, A whose length is 3. So I removed one edge from the cycle and I added one new edge. So for this graph, I was able to remove one edge from the cycle and add new edge such that I got a new cycle of the same length. So in this case, I will return yes. If I was not able to do so, I would return no. So basically, we are given a tree which has n nodes and n minus 1 edges, and one more additional edge is added to it. So we are given a graph which has n nodes, n minus 1 edges, which is connected and which also has one cycle. And we need to tell, can we replace one of the edges of the cycle with an additional edge such that a new cycle of same length is formed? If yes, we return yes, otherwise we return no. Okay, is the question clear? Now let's go line by line. In the given tree, an additional edge exists between two nodes, resulting in the presence of a cycle. What I said, a tree was given, in that we added a new edge, so a cycle is formed. Our objective is to determine whether it is possible to remove an edge from the cycle while introducing a new edge between any two nodes, such that new cycle is formed maintaining the same cyclic length as the original cycle. That is what I told. We need to tell whether we can remove one edge from the given cycle and add a new edge such that the new cycle which is formed has the same cyclic length as the original cycle. Okay, the newly formed cycle should not be same as the original cycle, so you cannot remove an edge and add a new edge at that same place. Okay, removed edge and the new edge should be between different nodes. Okay, one of the nodes can be repeated, but it cannot be between the same two nodes. Return yes if it is possible, otherwise return no. The cyclic length of a tree refers to the count of edges involved in constructing the cycle. Also, you cannot add the same edge which you have deleted. If two nodes are connected with two edges, then there is a cycle of length 2. Okay, so we cannot add the same edge, and also if there are two nodes with two edges connected, that is also a cycle of length 2. Okay, so first of all, please let me know if the question is clear, and then we'll move on to the solution. Is the question clear? This comes in graph DSA. Again, repeat it, please. Okay. Yes, like you can say this is a graph question. Okay. So let me just quickly repeat the question. So basically, suppose we have a tree. Okay. So the tree has n nodes and n minus 1 edges, right? And it is a connected graph. Okay. So let's say this is my tree. Okay. A, B, C, D, and E. Now if you add a additional, if you add a additional new edge to this tree, then there will definitely be a cycle. Okay, take any two nodes. Okay, let's take B and E. So I can add a edge between them, so I have a cycle A, B, E, C, A. Okay, so something like this is given us to the question. There was a tree with n nodes and n minus 1 edges, and a new additional edge was added. So it formed a graph with exactly one cycle which was connected. Okay, so this is given in the question. Now they are asking, can we delete one edge from the cycle and add one more edge between any two nodes such that again a cycle is formed, but this should be of the same cyclic length as it was of the original graph. Now here the original cycle is of 4 length. Okay, I need to delete any edge of the cycle. Okay, so I can delete edge between AC or CE or EB or AB. Let me delete an edge between A and B. Okay, now I need to add one more edge between any two nodes, but that should not be between A and B. I mean, I cannot remove and add the same edge. Okay, and I need to tell, can I get the same cyclic length? That is, can I get the same cycle of length 4? That is what they have asked. Okay, so what I can do, if I look at this graph, I have removed an edge between A and B. If I add a new edge between A and E, okay, or let's say I need the length to be 4, right? So what I can do, I can add a edge between B and D, right? So let us do that. So there is A is connected to C is connected to E is connected to B, and E is also connected to C is also connected to D, right? and this is the current graph. I remove the age between A and B. If I add a new age between D and B, I again get the cyclic length 4, right? So I will return yes. If I can delete one of the ages of the previous cycle and add a new age between any two nodes such that I get the same cyclic length. If there is even one possibility, then I will return yes, otherwise I will return 0. Now here another possibility was A is there, then A and C are connected, C and D are connected, C and E are connected, E and B are connected, right? I removed an edge between A and B. I could have added age between B and C, but this will give me a cycle length of 3, and the original cycle was of length 4, right? So I wanted to obtain a cycle of length 4 only, and it was possible. So I returned yes. Now, if is the question clear? Is the question clear now? Okay, great. So now, see, understand one thing. Let me take a random example. Okay. So let us take a. So this is the cyclic part. Let me take some other nodes of the tree. Okay. Let us take this. Okay. So this is my graph. Okay. Currently. Now the cycle length is 5. Okay. I need to remove an edge and the new cycle should also be of length 5. Okay. Now tell me, if I remove an edge, suppose I removed this edge. Okay. Now my cycle, now this cycle which was of length 5, still it is connected with 4 number of edges. So this is first edge, this is second edge, this is third edge, this is fourth edge, this was the fifth edge. Okay. Now what I can do is, I can select one of the two nodes of either this or this between which I have removed the edge. Okay. And I can connect it to a node which is not a part of the cycle. So if I, let's say, if I connect this with this, okay, now have I formed a cycle? So this is my first, this is my second, this is my third, this is my fourth edge. Okay. Or no, I think we should have, just a second. So this is 1, 2, this is 3, this is 4. Okay. So see, now this is 1, this is 2, this is 3, this is 4, and this is 5. I have again got a cycle of length 5. Okay. What other thing could I have done? Instead of this, I could have started a edge from here, and I can connect it with a node which is not a part of this cycle. So this edge I have removed. Now we can see this node is not a part of cycle. Suppose I connect this with this. So now I again get a cycle. This is first, this is second, this is third, this is fourth, and this is fifth edge. Again I get a cycle with 5 number of edges. This is my first node, second node, third node, fourth node, and fifth node. Are you getting my point? So basically what I did, I removed an edge from the cycle, and between any two nodes, so between any two nodes I removed an edge which were a part of this cycle. Now I added a new edge such that one of the nodes is the part of the previous cycle, and one of the nodes is not a previous part of the cycle, and the new edge formed will always have the same length. Because basically what's happening, see, in the previous cycle, this node, this node, this node, this node, and this node were apart, right? After I removed this edge and added this edge, this node, this node, this node, and this node are still a part of the cycle, right? Let me make it plus sign. These are still a part of the cycle. This is no longer a part of the cycle. So this is removed and this is added. So from the cycle, one node is removed and one node is added. So the length will remain the same. Here also, this is a new node in the cycle. This was the part of the old cycle. This was a part of the old cycle. This was a part of the old cycle, and this was a part of the old cycle. This was also a part of the old cycle, but it is not a part of the new cycle. Are you getting my point? So if I remove an edge between two nodes which is a part of this cycle and add a new edge between two nodes such that one node is a part of the old cycle and one node is not a part of the old cycle, I will get the cycle of same length. Is this much clear? Is this much clear? Please let me know. Hello, please let me know in the comments if this much is clear. Okay, great. So basically what I said, in order to form a cycle of the same cyclic length, we remove an edge from the cycle, add a new edge between two nodes such that one node is a part of the previous cycle and one node is not a part of the previous cycle, right? Now, when can we not do this? See, listen to the last statement again. We add a new edge between two nodes such that one node is a part of the cycle, previous cycle, and one node is not a part of the previous or the original cycle. If there are no nodes which are not a part of the original cycle, means if all the nodes are the part of the original cycle, we cannot do this. So for example, if my n is 5, and if all the nodes are a part of this cycle, so if this is my cycle, suppose I remove this, okay, original cycle size was 5. Suppose I remove this edge, now I need to add a new edge. So suppose I add it between this and this will result in a cycle of 4. This and this will result in a cycle of 3. This and this will result in a cycle of 2. But I will never get again the cycle length of length 5. Is this much clear? So whenever all the nodes are forming a cycle, the answer is no. If all the nodes are not a part of the cycle, if there is at least one node outside the cycle, answer is yes, we can form a new cycle of the same cyclic length. Now how can we check if all the nodes are a part of cycle or not? Easily, one way is to calculate the cycle length. Okay, so basically you call a DFS, and whenever you find a cycle, you mark the nodes by backtracking which were a part of cycle, and you count how many nodes are a part of cycle. Okay, that is one way. That is a bit tough way for this question, okay, because we do not need the exact cycle size, we just need to know whether all the nodes are a part of cycle or not. So how can we easily check? If all the nodes of the cycle are, if all the nodes of the graph are a part of cycle, then each node will be connected to two adjacent nodes. That's all. So let me take 6 nodes. Okay, 1 2 3 4 5 6. All the nodes are a part of cycle. This is connected to two nodes, 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 this is connected to two nodes. So simply, if each and every node occurs in two edges, it means it is forming a cycle which has all the nodes included in it. We will return no. If that's not the case, we will return yes. So there are again multiple ways. First of all, we can take a count array, which will basically, let's say, count of n plus 1, where count of I will denote the number of edges of which I is a part of. Okay, that is one way. Another way is to create a adjacency list for all the elements, and if the adjacency list size for all the elements is 2, it means all the nodes are a part of cycle, we will return no. If the adjacency list size of any element is less than 2 or greater than 2, then all the nodes are not a part of cycle, and we will return yes. Okay, so I will be using this method. I will be forming an adjacency list. So let me take this. Okay, so what I have done is, see, these are the edges, there are n edges, so I have traversed the n edges, and ith edge is between edges of I0 and edges of I1. Okay, so in the adjacency list of edges of I0, I have pushed back the element edges of I1, and in the adjacency list of edges of I1, I have pushed the element adjacent edges of I0. So basically I have formed an adjacency list. Then I have taken one flag variable which I have marked as 0, and for all the elements from 1 to n, if the adjacency list size of any element is not equal to 2, I will immediately make flag variable equal to 1 and I will break. So if the flag variable value is 1, so there was some element whose adjacency list size was not 2. If it was not 2, all the nodes are not a part of this cycle. If all the nodes are not a part of this cycle, we can form a new cycle of same length. So I have returned yes. Otherwise, I have returned no. Is this clear? Please let me know. Where the conditions doesn't fulfill, please tell with another example. So I also told another example. Mohit, can you tell again whether you want me to repeat or not? Code share. Yeah, sure. Just a second. Let me share the code. I need to focus. I will see tomorrow. Okay, no problem. Mohit, please let me know whether you want me to repeat this. Code for third question. Can you please tell me the cycle detection DFS approach? So I would have told you, but what I will tell you is that it will not work on this depending upon the constraints. You might get segmentation error, okay? Because a lot of functions call will be made and the constraints are such that you will not be able to make in this. So let us not discuss that here at present. Okay, so let us move on to the last question, which was quite good. Okay, make array. Okay, so now first of all, let me tell you about this question. Okay, the fourth question, or let's go line by line because there are a lot of things. Okay, we will also conclude the question at the end. For an array A having binary numbers 0 and 1, let us define a function f of I for index I for all I between 0 and n minus 1, which is the bitwise XOR of all the numbers in the array from I to n minus 1. More formally, f of I equal to a of I XOR a of I plus 1 XOR a of I plus 2 up to XOR a of n minus 1. So what it basically saying is, suppose you have an array which is binary array. Now, what does binary array mean? All the values in the array will be either 0 or 1. Okay. So they are saying that if all the values in this binary array are 0 and 1, let us call a function f of I as the XOR of all the elements from ith index to n minus 1th index. So f of I will be a of I XOR a of I plus 1 XOR a of I plus 2 XOR up till a of n minus 1. Okay, so if let's say array size is, let's say, 6, so f of 2 will be what? A of 2 XOR a of 3 XOR a of 4 XOR a of 5. Okay, and a of f of 3 will be what? This. F of 4 will be what? This. F of 5 will be what? This. Also, just let us understand, f of I will be either 0 or 1, because since this array is binary, taking XOR of some elements, if the number of ones are odd from I to n minus 1, my answer would be 1. If the number of ones are even from I to n minus 1, my answer would be 0. Okay, so now let's move on to the next statement. Geek is given a string s of digits from 0 to 9 and two numbers num and k. Geek wants to create an array ARR of binary numbers. Initially, all the array is filled with 0 as follows. Okay, so basically, Geek has been given a string which contains digits from 0 to 9. Geek is also given two integers which are nothing but num and k. Geek wants to form an array ARR such that now this array is binary. So the values in this array will be 0 or 1 such that he considers the starting index j, where j is between 0 and n minus 1 of all suffixes of s, whose decimal representation, no leading zeros, is divisible by num. Okay. What will be the code forces rating for the fourth question? See, it was like, I would give it around 2000. Okay, because there are a lot of things. Okay, so you can say 1900, 2000. That is what I will give me. Quickly tell me hint or data structure in fourth question. We'll just move on to the solution. First, let us understand the question properly, so that if someone has not understood the question properly, then they can also get it. Okay. Now, how is the array ARR formed? He considers the starting index j, where j is between 0 and n minus 1 of all the suffix of s, whose decimal representation, no leading zeros, is divisible by num. Okay. So consider all the indexes j such that the suffix starting with index j of the string s. So what would be that suffix? S of j, s of j plus 1, s of j plus 2, up till s of n minus 1. Okay, where n is the length of the string. So if this suffix, s is a string with digit 0 to 9. Okay, so this suffix, if we convert it into its decimal representation, so let's say this character was 2, this character was 3, this was 7, let's say here we had 8, and let's say here we had 0. So the decimal representation of that suffix is 23780. Okay, so what they have told is, initially all the array elements are 0. Okay, for all the ARR elements which the geek wants to make. Now he considers all the indexes j such that the suffix string of s starting with index j, if it is converted into its decimal representation, it is divisible. It is divisible by num. Okay, num is given as in the input. So let's say my num was equals to 2. So 2 is divisible by this, so I will consider this index. Okay, so for all the suffixes starting from where that decimal representation of the suffix is divisible by num, we will consider those indexes. Now what to do with those indexes, that is given in the further line. Is divisible by num. Okay, no leading zeros means in that suffix, if there are leading zeros, when you convert it into its decimal representation, leading zeros will go, right? Now in this array ARR, geek has a choice to make the element at index j, starting index of all the suffixes that satisfy the above condition, as 1 or let it be 0. So for all the indexes j, starting from where, if I consider the suffix of the string and that too in its decimal representation, if that number is divisible by num, for all such indexes j, the geek has choice whether to make ARR of j equal to 1 or let it be 0, which was initially equal to 0. Okay, it has two choices. For all the indexes where the suffix is not divisible by num, there is no choice, they will remain 0 only. Okay. Okay, so this is the way to create the array ARR. Okay, your task is to find the total number of array which geek can make by following the above procedure, whose sum of f of I, whose sum of f of I, we saw the f function where I is between 0 to n minus 1, it is exactly k. Okay, more formally, you need to count the total number of arrays ARR whose sum of f of I, that is f of 0 plus f of 1 up to f of n minus 1 is k. The answer can be very large, so print 10 to the power 9 plus 7 modulo. So basically, see, let's say my string size is 5. Okay, so let's say my string is 1, 2, 3, 4 and 5. Okay, let's say my num is 3. So first of all, I will take an array ARR which I want to form. Initially, all the elements will be 0, right? Now for all the indexes j, where the suffix starting from that index is divisible by num, I have two choices, either to place 1 or 0. So if I consider this suffix which has value 5, 5 is not divisible by 3. So this will remain 0 only. Now if I consider this suffix 45, 45 is divisible by 3 if I look at it by a decimal representation. So at this position I have a choice either to replace 0 with 1 or let it be 0. If I consider this suffix 345, that is also divisible by 3 because the sum of the digits is divisible by 3. Okay. So in this case also, here I can place 0 or 1. If I consider this 2, 3, 4, 5, this is not divisible by num, that is 3. So here it will remain 0 only. If I consider the complete number 1, 2, 3, 4, 5, this is also a suffix. This is divisible by 3. So here also I have two choices, either to place 0 or 1. So how many total arrays are made? Total 8 possible arrays are made, because at this position I have two choices, either to place 0 or 1. Here I have only one choice, that is 0. Here I have two choices. Here also I have two choices, and here I have only one choice. So the total number of possible arrays ARR is 2 into 1 into 2 into 2 into 1, which is nothing but 8. Is this much clear? First, let me know. Is this much clear? How is the array ARR formed? How there are multiple choice possible for array ARR? What is num? What is k? Is this much clear? Please, someone let me know. Have we got 8? Clear, sir. Have we got 8? Okay. So is this much clear that here I have two choices, here I have one choice, here I have two choice, here I have two choice, and here I have one choice? Is that much clear, Rishabh? First, let me know. Is that part clear? Have we got two choices or one choice? Okay. So now understand one thing. Let's say I have three size array. Okay, ARR. Okay, and there are three elements. Here, suppose I have two choices, one or zero. Here I have only one choice, zero, and here also I have two choices, one or zero. So how many different total arrays will be possible? Here I can place zero. Here it will be zero only. Here also I can place zero. Now here I can place 0, here there will be 0 only, here I can place 1. Here I can place 1, here there will be 0 only, here I can place 0 or 1. Here I can place 1, here there will be 0 only, here also I can place 1. So there are four different choices to be made. Okay. So here there are two choices, here there is one choice, here there are two choices, here there are two choices, and here there is one choice. So each and every choice of this can combined with each and every choice of this. So there will be total four possible ways for the first three elements, and each and every choice of this can be combined with the two choices here. So total there will be eight choices. That is nothing but 2 into 1 into 2 into 2 into 1. Okay, great. So now what they have said, out of all the possible arrays ARR, how many number of arrays are possible keeping these conditions in mind, and summation of f of I for array ARR should be exactly equal to k. Okay. Now we discussed that f of I can be either equal to 0 or 1, because f of I is nothing but the XOR between all the elements of array ARR from index I to index n minus 1, and array ARR is binary array, right? So if from index I to n minus 1, if the number of ones is odd, my f of I will be 1. If the number of ones from ith index to n minus 1th index is 0, my f of I will be sorry, if the number of ones from ith index to n minus 1th index is even, my f of I will be 0. So either f of I will be 0 or f of I will be equal to 1, right? So in order to get summation f of I equal to k, there should be k ones in f of I values. So I should have k suffixes with odd number of ones. Are you getting my point? What I'm trying to say? Let's say my array ARR is 0, 0, 1, 0, 1, 1. Okay. So what will be my f of f value? My f value for this position will be 1, because f value at this position is XOR of this element. At this position, the f value will be XOR of these two elements. So it will be 1 XOR 1, it will be 0. The f value at this position will be XOR of these three elements, or I can say XOR between this and this, because this is nothing but the XOR between these two elements, right? F of I equals to f of I plus 1 XOR array of I, right? So this will be 0. F value at this position will be the XOR between all these four elements, or I can say between this 1 and this 0, so it will be 1. F value between these five elements will be the XOR between these five elements, it will also be 1. F value between all these elements will be XOR between all these elements, and that will also be equal to 1. So the summation of F values is 4. Okay. So in this way, we need to form an array whose F value, summation of F value is exactly K. Okay. Now, see, basically, I can form an array division of I which will be either 1 or 0. It will be 1 if the suffix of a string starting from index I is divisible by num. Okay. So s of I plus 1 up till s of n minus 1. If this suffix string in its decimal representation is divisible by num, so modulo num is 0, then I will say division of I is 1. So that suffix is divisible by 1, is divisible by num, so that at ith index I have two choices, either to make it 1 or to keep it 0. And if division of I is 0, it means the suffix starting from ith index of the string s in its decimal representation is not divisible by num. So at that index, I do not have any choice. I will keep it 0 only. So there is one choice. Okay. So what will be the brute force approach? The brute force approach will be to call recursion. Just call a recursion function. Whenever there is a choice between 1 and 0, take both the possibilities. Whenever there is no choice, uh, do not take any choices, keep it 0 only. And at every step, count the number of suffixes whose XOR is 1. Okay. So if the number of suffixes whose XOR is 1 is 10, then the uh, summation of f values will also be 10, right? So what I can say is I can call a function, recursion function, starting with index 0 and number of, or starting with index n minus 1. Why am I starting with index n minus 1? So that I will fill the last position, then the second last position, because if I know the data of from ith index to n minus 1th index, it will help me while filling the I minus 1 index, because here f of I is nothing but the XOR of the elements from I to n minus 1, that is the suffix, right? So that's why I am moving in reverse direction. So what does this function tell me? It tells me to fill the n minus 1th index and count, let's say, uh, number of sub arrays whose XOR is 1 is 0. Initially it would be 0, and at the current position I will have two choices, either to make it 0 or 1, right? So basically, see, what I'm telling is, basically I am trying to make a recursive relation. So f of ij and 0 and f of ij and 1. Here I can call two functions. One I can call with n minus 1 0 0, and I can call function n minus 1 0 and 1. So what does this say? This is the starting point. Fill the n minus 1th index, the current f summation f value till now is 0. Initially it will be 0 only. and the XOR subarray XOR starting from index n minus 1 is 0, or fill the n minus 1th index, the summation f value till now is 0, and the XOR value starting from n minus 1 index of the suffix will be 1. See what I am telling, what is this value? This is f of I value, okay? This is summation f value till now. This is f of I value. This is not the value in the array ARR, which is 0 or 1, because at ith index it may be possible that I cannot place 1. This is f of I value, but I can make the suffix starting from ith index to n minus 1th index, the f value to be 0 or 1 depending upon different combinations, okay? So now understand one thing. So that would be my starting point of the function. And when will we stop? After we reach minus 1 here, because till 0th index we will fill, and at minus 1 index we will stop. And at that time, if this value, summation f value is k, we will do answer plus plus, that we have got one combination, right? So in general, what the recursion function will look like? If I say you f of ij0, listen to this clearly, okay? You will get it. What does this say? Consider the suffix starting from index I, okay? Consider all the suffixes starting from index I if the summation, if, or I can start this with k, okay? Sorry. And I can decrease it. Every time I get a sub array with value 1, I can decrease it, okay? So, okay, let's not look at this right now, just look at this function, okay? F of ij0 and f of ij1. What does this recursive function say? It says that consider all the suffixes starting with index I. We want the summation f value to be j, and the suffix starting with index I has XOR 0. What does that mean? That summation summation k equals to I to n minus 1 f of k is equals to j. F of I is 0. That is what it is telling. If all the suffixes starting from index I, if we calculate the summation of f of I, it should be equal to j. And the suffix starting with index I has the XOR value 0. How many such combinations are possible? That will be given by this function, okay? What will this function tell me? Consider all the suffixes starting with index I whose summation f value is j, and the suffix starting with index I, that is from I to n minus 1, that has value 1, okay? So if I sum up these two values, what it will give me? It will tell me all the possible array combinations for indexes I to n minus 1 such that summation f value is equals to j, okay? So what we need to return is, initially we can call 0, k and 0 plus f of 0, k and 1. This is my answer. This I will call initially function. This I will call, okay? What does this say? Consider all the suffixes starting with index 0, and the suffix starting from index 0 has XOR 0, and the summation of f values of all the suffixes starting with index 0 is k. Tell me all such combinations, plus consider all the suffixes starting with index 0 and the summation of f value is k, and the suffix starting with index 0, that is from 0 to n minus 1, that suffix itself has XOR value 1, right? Because f of 0 can have either value 0 or 1, okay? So tell me the suffixes starting with index 0 whose summation f value is k and f of 0 is 0, and plus tell me the suffixes starting with index 0 whose summation f value is k and f of 0 is 1. Is the notation for this line clear or not? First tell me that much, then we will write the recursive function. Don't look at the above crossed recursive function, okay? There I made a little bit mistake. Is this clear? So initially from the main function I will call this, and then further will go, okay? It's clear. Now let's say at ith index division of I is 1. It means the suffix from I to n minus 1 is divisible by num. So at ith index I have two choices, 0 or 1. Okay. Suppose I take 1, suppose I take 0. Here also suppose I take 1, suppose I take 0. Okay. If I take 1, then I will tell that consider all the suffixes starting with index I plus 1 and the XOR starting with I index had value 0. Okay. See what I want, summation f value equals to j. Okay, for this function. Now the f of I was 0, right? So summation f value from k equals to I to n minus 1 is j, and summation k value from I plus 1 to n minus 1 will also be j, because f of I is 0. So I will say that if the XOR value starting with index 0 starting with index I is 0, then here I will need j only, and what will be the XOR value from I plus 1 to n minus 1, that will be 1. Okay, and here it will be f of I plus 1 j and 0. Now understand this thing, f of ij0 denotes number of suffixes starting with index I whose sum of f value is j, and the suffix starting with index I, that is f of I, has value 0. Okay, is equal to, now tell me, so if from I to n, if from I to n minus 1, if sum is j and if f of I is 0, how we can know f of I is 0? Because this is 0, right? Then summation from I plus 1 to n minus 1 will also be j. That's why I have called I plus 1, and here I have called j only. It will remain j only. And why I have called 1 here? Because f of I is, don't confuse this recursive function with this f. Okay, this f is the XOR from ith index to n minus 1th index. We know that f of I is 0 because here in this recursive function we have wrote 0. Okay, now if we need this to be 0, and if at the ith index I place 1, what I am saying, f of I is 0, so a of I XOR a of I plus 1 up to a of n minus 1 is 0. That is what I am telling by using 0 here. And I am telling if I take 1 at the ith position, so this is 1. Now if the XOR of this complete is 0, if this much is 1, then this much should also be 1, then only 1 XOR 1 will be 0. So that's why I have passed 1 here, that from I plus 1th index to last, f of I plus 1 should be equal to 1, and considering all the suffixes, their sum of f value should be equal to j only. Okay, and here if I take 0, so if I take 0 at this position, and if f of I is also 0, then from I plus 1 to n minus 1, this should also be 0, which is nothing but f of I plus 1. So I have passed I plus 1 index, and I have called that the sum of f value should be j, and there should be 0 at I plus 1th position also. So this value will be equal to sum of this and this. Similarly, I can fill this. Here the XOR value starting with ith index is 1. If I take 1 at the ith index, so I will call recursive function on index I plus 1. This will become j minus 1. Why? Because summation f value is how much? J, starting from I. Now at ith index, if I have 1 in the suffix XOR, then summation I plus 1 to n f value must be how much? J minus 1. So this is I plus 1, j minus 1 and 0, because from I plus 1 to n minus 1, it should be 0. At ith index, I took 1. So the total will be XOR will be 1. Okay. And here it will be f of I plus 1, j minus 1 and 1. So this will be my recursive function. First, let me know, is this recursive function clear? Is the recursive function clear? Someone please let me know. Okay, great. Now if we call this recursive function starting with these two values, it will give us the answer, but the time complexity will be exponential, so we need to convert it into polynomial. Now we want to convert the recursion into polynomial. So can we think of dynamic programming? Here also, if you further call the functions, you will see overlapping sub problems. Okay, that same sub problems are repeated again and again, so we can use dynamic programming. So now I want to use the tabulation method where I can fill the table. Okay, so basically I can fill the table using this relation. Okay, f of I j 0 is nothing but f of I plus 1 j 1 plus f of I plus 1 j 0, and f of I j 1 is nothing but f of I plus 1 j minus 1 0 plus f of I plus 1 j minus 1 1. Okay, so can I say dp of I j 0, that is, if we consider all the suffixes starting with index I, if the summation values uh, of f values is j, and if the suffix starting with I index has x or 0, I can either take 1 or 0 here. So I can say it would be dp of I plus 1 j and 1 plus dp of I plus 1 j and 0. Okay, and similarly dp of I j1 is equals to dp of I plus 1 j minus 1 0 plus dp of I plus 1 j minus 1 and 1. Basically I have done nothing. I have converted this recursion function into dp table where I have taken I, j and this third column. Okay, and what will be my dp size? I will take dp size of n plus 1, n plus 1, or let's say k plus 1. Okay, because this is the summation f value, I do not want to go further k, and here I will take 2 because there are two choices, 0 or 1. Okay, and I will fill this table, and what I will return? I will return dp of 0 k 0 plus dp of 0 k 1, which basically denotes consider all the suffixes starting with index 0 such that the summation f values over that combination is k, and the suffix starting with index 0, that is f of 0, has value 0, or consider all the suffixes starting with index 0, basically consider the whole array, and summation f value is k and f of 0 value is 1, because f of 0 value can be either 0 or 1. Okay, so finally we will return this. So if we look at the code, okay, so what I have done, I have taken n as the size of the string ij, then I have taken one division array and one remainder. Okay, and I have taken mod as 10 to power 9 plus 7. Now first of all I want to fill this division array. Okay, so how can I fill that? See, I have been given a string. Okay, its length can go up till 10 to power 5. So I cannot store that much big number into an integer. So at every step I will take modulo. Okay, so let's say my string is 1 2 3 4 5 6 7 8 9 1 3 4 9. Okay, suppose I want the suffix this modulo num. Okay, so what I can say? I can say remainder equals to 0. I can add one by one all the digits. So I can add this digit. So basically how this number will be formed? First of all, the number is 0. I multiply it with 10 and add 8. So I will get 8. Now I multiply 8 with 10 and add 9. I will get 89. Now I multiply 89 with 10 and add 1. I will get 891. Now I will multiply 891 with 10 and add 3. I will get 8913. Now I multiply 8913 with 10 and add 9. It will give me 89139. In this way I can get this number. Now there is a concept for modulo, that if you take modulo for the complete number or at every step, it will give you the same result. So what I will do, I will traverse this digit by digit, and at every step I will say remainder is equals to remainder multiplied by 10 plus the digit which is at that place. Suppose it is 9. So plus 9 and modulo num. Okay. So even if you take one by one digit and take modulo at every step, it will give you the result. Okay, because we cannot store that much big number. So for all the suffixes I am calculating. So for all the suffixes, first remainder is 0. Now I am calculating for suffix starting with index I. So for j equals to I to n minus 1, remainder equals to remainder star 10 plus s of j minus 0. Why? Because that is character. So I need to do minus 0 to convert it into numerical value modulo num. If remainder is 0, it means that suffix decimal representation is divisible by num. I will say division of I is 1, so that there are two choices, either 0 or 1. Else I will say division of I is 0. Okay. Now I have taken this DP table of size 1002 cross 1002 cross 2. Okay. Let us fill it. So in tabulation, first of all, we fill the base cases. So what are the base cases? First of all, I have marked all of them as 0, okay, in order to avoid any kind of garbage value. Then from line 42, I have started filling the base case. Now what is the base case? If I want summation f value to be 0, starting with any suffix, I have only one possibility. What? Take all the digits as 0. If I want summation f value to be 0 for all the if I want summation I f of I to be 0, so f of I plus f of I plus 1 plus f of I plus 2 up to f of n minus 1 to be 0, individually all of them should be 0. That is only one possible way. From I to n minus 1, take all of them as 0. So there is only one possibility. Okay. So what I have said is, uh, for I equals to 1 to n, considering all the suffixes, dp of I 0, that is, what is the second index denoting in dp table? That is denoting summation f value. So if I want summation f value to be 0, and if f of I is 0, this third value is denoting f of I value. If it is 0, there is only one way to take all of them as 0. And dp of I 0 and 1 is 0, because if you want the summation f value to be 0, you cannot take f of I to be 1, then the summation f will not be 0. Okay, so I have taken that as 0. Even if you do not do that, that will be okay, because initially I have filled the complete table with 0. Okay. Now I have filled the last position first. So if division of n minus 1 equals to 1, then there is only one possibility. Then I have two possibilities, either to place 1 at last position or to place 0 at last position. So dp of n minus 1, 0, 0 is 1. If I want summation f value to be 0, starting with last index, there is only one suffix. And if I place 0 at that place, there is only one possibility. And if I want the summation f value to be 1, and placing 1 at the last position, then also there is only one possibility. Okay. Now I will fill the remaining table. For I equals to n minus 2 to 0, for j equals to 1 to k. If division of I is 1, if there are two possibilities, then dp of ij0 is the summation of this, and dp of ij1 is the summation of this. If division of I is 0, it means I cannot place 1 there. There is only one possibility, 0. Then dp of ij0 will be equal to dp of ij0, because since I cannot place 1 there at the ith position, if I want to get f of I equals to 0, f of I plus 1 should also be equal to 0. It cannot be 1. Okay, like I have done in line 58. And similarly, dp of ij1 equals to dp of I plus 1, j minus 1 and 1. If I want f of I value to be 1, and if there is no choice for ith index in array, there is only 0 value, f of I plus 1 should also be equal to 1. So I have taken that, and at every step I have taken modulo, and finally I have written dp of 0k0 plus dp of 0k1 and modulo mod. Okay. Let me also share the code as requested by someone. So we have solved this question successfully. I hope you have understood it. Please let me know in the comments. Okay, so we have discussed all the four questions. I know the fourth question was a bit tough. I would recommend we have gone very slowly, step by step. So if you have not understood it, I would request you to again watch the video and you will get it. Also, write down along with me, okay, and try to understand. That will be even better when you write it down on the paper, okay. And I hope you have understood all these solutions. And if you like this video, if you have understood the solutions, you may also consider taking a screenshot and sharing it on LinkedIn, tagging me and Geeks for Geeks. And I think we can end the live stream for today here. And thank you for joining. Have a good day, good night. Yeah, thank you. We can end the stream. Okay, welcome, Ashish. And if you have not liked the stream, make sure you give it a like, okay, before leaving. Okay, thank you.